All right, in this section, 8-3, we're going to be looking at trigonometric identities. So the idea of an identity is essentially a statement of equality between two expressions that is true for all values of the variable. So when you look at this basic equation here, you can minus a 3. So x has to equal 1. There's only one answer. On this one here, you can combine the x plus 3x, you get 4x equals 4x. So no matter what you plug in for x, both sides are going to be equal. So I can put in 2 and put in 2 here. They're going to be the same thing no matter what. So it's true for all values of x. So that's what an identity is, and we already are familiar with some of them. Here is the ones you've seen before. These are the reciprocal identities, meaning if I have sine of an angle, it's equal to 1 divided by the cosecant of that same angle. So sine of 30 is equal to 1 divided by the cosecant of 30. So, and all these are true. We know all the reciprocal ones, how those all interact. We've used those on the unit circle before and solving some trig problems. Quotient identity, we've seen the tangent one when we're doing our unit circle especially. We got tangent is sine over cosine, and therefore cotangent, if you just flip it, is cosine over sine. By the way, I will give you a reference sheet, so you do not need to memorize these, although if you do enough of these problems, you'll probably recall quite a few of them. Here's some new ones for you. And in class, we can go into more details on how some of these other ones are derived. I'll give you some of the basics on this one, for example. So a Pythagorean identity, sine squared plus cosine squared of an angle equals 1. If you think back to our unit circle, we had a hypotenuse of 1 unit. And this value represented your sine, this value represented your cosine. So if you think about Pythagorean theorem, we have sine squared plus cosine squared equals 1 squared. That's weird. Why didn't that type up? There you go. There we go. Equals 1 squared. So in other words, they write it this way, sine squared of theta. I think because we don't want to write all those parentheses every time. But when you see sine squared theta or cosine squared theta, what it really means is, you take the sine of the angle and then square it. So you can't just square the sine. That doesn't make any sense. And you don't want to square the angle. So this notation just means, oh yeah, I'm going to take the sine of some angle, and once I get the result, I'll square that result. Okay. We can also see there's a few other ones that really are derived from this one. I'll show you how in class if you'd like to. But we got tangent squared of theta plus 1 equals secant squared theta, and 1 plus cotangent squared theta equals cosecant squared theta. We got some cofunction identities. They use radians. You could also use degrees like over here. So the sine of essentially 90 minus theta is equal to cosine of theta, these angles being the same here. So for example, let's say my theta was 60. Well, the sine of 90 minus 60, or pi over 2 minus 60, equals the cosine of 60. And 90 minus 60 is 30. So the sine of 30 is actually equal to the cosine of 60. And we saw that in a unit circle. For example, with 30 and 60, they had the same values, but they were just flipped. So the sine of one is actually the cosine of the other. We got some negative angles. I'd say these aren't as common, but they do pop up, and you can experiment that. Try out a couple angles, see what happens. But yeah, these are probably the less used ones versus some of the others, but they might pop up here and there. Also, just bring your attention, you can rearrange any identity if you need to. So if we have sine squared plus cosine squared equals 1, that's our Pythagorean identity, I could also rearrange that and say, okay, well, if I move the cosine squared to the other side, it'd be sine squared theta equals 1 minus cosine squared theta. They don't list this because, you'd have to list every combination of things you could rearrange. So this is also an identity. It's also true because I'm just moving something. So actually, any of these you could totally rearrange if you'd like to. On all of these, actually I could do I can multiply by cosine here, and cosine times tangent equals sine. That could be another rule. They don't list it here, but you can just rearrange any of these. And one other little note to make is, for example, sine of x over cosine x equals tangent. We know that. It also is true if you use it to other powers. So sine squared over cosine squared is actually equal to tangent squared. So, and it could be any power, sine to the third power or fourth power, whatever. So let's try a few examples out. So the idea here is to simplify the expression, put it in the simplest form possible, hopefully ideally just one trig function instead of here we can see we got 3 different ones going on. There's lots of strategies we'll talk about. One of them is try to get everything in terms of sine or cosine, since we have a lot of identities and properties that use sine and cosine. So for example, on this one, okay, wow, that's kind of a mess. I don't see that this is any of my current identities, any of my current, things in here. So let's just try to replace some stuff. Cosecant can be replaced with 1 over sine of x. Cosine, I'll just leave the same. And cotangent is cosine over sine. And you'll learn lots of different tricks along the way. One of those tricks is not to necessarily change everything. Notice I didn't change the cosine. I could change that into 1 over secant, but secant doesn't have any interaction with any of these other ones. So don't necessarily need to change everything. In this case, I'm changing everything into terms of sine and cosine because maybe there's a chance things will combine or cancel or whatever. In this case, I'm multiplying this together, so I have a cosine times a cosine, so that's cosine squared. I would then notice like, oh, I have some fractions, but they're the same denominator already, so I could basically combine these into one fraction, 1 minus cosine squared x all over sine of x. And if I look back to my properties, 1 minus cosine squared looked familiar. It's actually one that I brought to your attention. When we rearrange this Pythagorean identity, 1 minus cosine squared is really just sine squared. So I can replace that with sine squared over sine. And basically this sine would cancel out with one of these sines, so we're just left with sine of x. Let's try another example over here. We have cosecant over cotangent. Again, that doesn't look like any of the properties I've already seen before. So let's just start replacing. We could do, for example, cosecant is 1 over sine, and cotangent is, cotangent is cosine over sine. So I know this in some ways looks more complicated, like you can see over here too. Sometimes they get worse before they get better. All right, so I've got a fraction divided by a fraction, so how about I multiply by the reciprocal? I'll keep this one the same, and I'll multiply by the reciprocal, so sine over cosine. If you notice now, we have a sine on top and a sine on bottom, so those cross out, so I'm left with 1 over cosine, and I can actually go one step further. 1 over cosine is just secant. Okay. I'm just trying to show you some of the tricks of the trade. Every problem's going to be a little bit different depending on what you're presented with. So just try things out. Often, I try one, it doesn't go in the direction I thought, so I try something else. Another thing is to realize there's more than one way to necessarily get to the answer. So somebody could have done this problem a different way and still got the same result. Let's try one last one here. Again, 1 minus sine, 1 plus sine. I know I have some properties that involve like a sine squared, like this here is sine squared, like maybe I could do 1 minus sine squared, but I don't have that here. I just have sine to the first. So another trick is, well, maybe I'll just multiply it out, like FOIL it out. So 1 times 1 is 1. 1 times sine of x is plus sine of x. Negative sine x times 1 is negative sine x or minus sine x. And negative sine x times sine of x is negative sine squared of x. These middle ones should actually cross off, so I'm just left with 1 minus sine squared, and that is one of my properties. I can just replace that with cosine squared. So again, these are a bit of a puzzle. You need to kind of try to work them out, try something, replace something, see where it takes you. You can always try something else, and the more you practice these, the easier they'll get.